Hi everyone, we are going to discuss power series today. So actually, this is a kind of series, and this is an infinite series. The only thing is here you have a variable x inside the series, right? This power series has a variable x. That's the difference between series and power series, right? So here C sub n's are coefficients of this power series, and x is a variable. Uh, so for instance, this is a small example. So power series x to the n. So this is called a power series in x. This one also a power series in x, right? So let's talk about the convergence of this power series, because x is a variable, so it has a convergence interval uh, in which this power series converges or diverges, right? So let's find out what values of x this power series converges, right? So when you plug this number for x into the series, you can see that the series is convergent. So that series converges to 1, right? And if you plug this number into the series, you get a geometric series. Then, so because the common ratio is less than 1, that means this infinite series is convergent. So this is the sum of this series is equal to this. That means, so when x is equal to 1/4, so this power series converges to this number. If you plug a number which is bigger than 1, for instance, let's plug this number into the equation, then what happens? This is a geometric series, and the common ratio is greater than 1. Therefore, this series, we know that because the common ratio is greater than 1, this series is divergent. So for that number, that value, this power series is divergent, right? So we can conclude that because this looks like a geometric series, but here we have a variable. So if this common ratio, this is the common ratio, x is the common ratio of this power series. If this common ratio is less than 1, and this power series is convergent, otherwise that means the common ratio is greater than or equal to 1, this power series is divergent, right? So let's look at another example. So here we have this one here, this power series, and clearly if you plug this number into the equation, that power series converges to 1. So you can see that when you plug this number 1 into the power series, that power series become this geometric series, because the common ratio is less than 1. This geometric series is convergent. That geometric series converges to this value here, 1 over 1 minus r is 1/2. Then this converges to 2. So if you plug uh, this number, if you plug 2 into the power series, so what will happen? The power series become the sum of ones. So you add up ones infinitely times. That means this the series divergent, right? So for this point, for this value, the power series is divergent, right? So how do you find the radius of convergence of a given power series? Think you may have learned how you find the radius of convergence of a power series or interval of convergence of a power series last semester, I think, under differential equation. So you have learned how to find a radius of convergence of a power series and the interval of the convergence of a power series, right? So you should brush up your knowledge of that. So I will do this example. Let's do how to find the the radius of convergence as well as the interval of convergence, right? So this is the power series, right? And so we apply ratio test. So a sub n plus 1. So here you consider the modulus of that. So this is your an. So this is your a sub n term. You find this ratio. You can see that x to the power n plus 1 and 2 to the n plus 1. Here you have x to the n and 2 to the n. When you simplify that, modulus sign and x mod of x divided by 2, right? So when you consider the limit n goes to infinity, so here there is no n term, so this does not depend on n, then therefore this ratio approaches mod of x over 2. So if this one is less than 1, what happened to that series? That power series is convergent. So mod of x less than 2, and that power series, if your variable x in between -2 and +2, this power series is convergent. The way around, that means x mod of x greater than 2, that power series is divergent, right? What happened to boundary points? Here you have -2, +2. So we know that this is a power series in x, or you can say this is a power series centered or around 0 or centered at 0, right? So you can express anyway, right? So I am saying this is a power series in x, right? So the center is 0. So this is the radius r. In this case r is equal to 1. The radius is 1. Now you have to check these 2 points. So inside these two values, so you know that this power series is convergent, and outside of this series that we don't know about the boundary. So let's check whether that power series is convergent at these boundaries, right? Let's check that one now. So when x equals 2, when you plug that number into the power series, that power series becomes this infinite series 1. So this is the sum of ones is infinity divergent, as well as when you plug x equals -2, that power series become negative to the -1 to the n, right? So this one also divergent. This one is also divergent because here's something like this: -1 you are adding, +1, -1, +1, -1. So this is a alternating one. If you sum even terms, so even terms here, so even terms 1 1 1, what happened when, so here if you consider even partial terms, so this one goes to infinity as n tends to infinity. If you consider odd terms, 2n minus 1, that goes to negative infinity. So therefore this one is not convergent. This one is divergent, right? This one is divergent. So at these boundaries the power series is not convergent, then we can find the interval of convergence. Let's denote I. So this one is the interval of convergence. So -2, +2. So in this interval, that power series converges. You look at this power series as well. So this power series is in this is a power series in x minus a, or you can say power series centered at a, or this power series about a, you can say like that. And as we did earlier before, we can find the radius of convergence and interval of convergence, right? So what I want to say is, for any power series there are only three possibilities. Either that power series converges only this point, converges only when x is equal to a, right? Or this series converges for all x, right? Or that power series converges in an interval like this. So there exists a positive radius r such that in this interval the power series is convergent. Outside of that interval the power series is divergent, right? So if you are given any kind of power series, it is one of these. It is one of these. Either that series converges only at the center, or that series convergence for all x, or that series convergent in on an interval like this. So that series convergent on an interval like this. So in this case the radius is 0, so this case the radius is infinity, and the final case it has a finite number for the radius of convergence.